All right, so we are on the big review sheet, the monster review sheet, the first one, and we are doing problem number 12, which says, write two equations for, first of all, this picture.
No.
All right. Now, when we say write two equations, you need to remember that this curve goes on and on and on and on. That shape is the shape of both a cosine and a sine. And you have no way of knowing which one it is. No one does. It could be either one. So we're going to write an equation of a sine curve and a cosine curve. And you will notice that I have a bunch of blanks in there. Because when I see a trigonometric equation to graph, there are four things that I can do to the graph. I can change its height by putting a number here, right? I can change its width by putting a number here. I can change its horizontal position by putting a number here. And I can change its vertical position by putting a number here. Everybody in agreement?
Yeah.
So I got to look at this equation, and first of all, I got to decide if I'm going to do sine or cosine first. It makes no difference. It's whichever you kind of see. I don't know, when I look at that, I see a sine curve. So I'm just going to start with that. I'm going to think of it from this dot to this dot. That is one period of the sine curve. So I can tell right away a lot of things real easily. I can tell what number goes in front. What number goes in front? 4. That's easy. I can tell what number goes here. That's the horizontal shift of the problem. What about this sine curve? There is none. It's starting exactly where it's supposed to start. Don't sine curves start at the origin? Yeah. If it started over here, then I'd have a horizontal shift, but it doesn't. It starts right where it's supposed to, so that's a 0. What about the vertical shift?
0.
That's 0. I can tell it hasn't been lifted up or down because look, it's going up to 4 and down to -4. It's not drawn up here somewhere. It's oscillating across the axis. The only number that's a little bit harder to find, and it isn't hard at all, but a little bit involves a little work, is this coefficient. What is that coefficient in charge of?
The period.
The period. And we know, because we've done it a million times, to find the period of a sine or cosine, you take 2 pi and divide it by that number, right? Now normally, I know that number, and I'm trying to find the period. I'm backwards. I know the period. What's the period? 4 pi over 3. So 4 pi over 3 is what you get when you take 2 pi and divide it by that number. You see what I'm doing? So 4 pi n equals 6 pi. And n equals 6 pi over 4 pi, which reduces to 3 halves. So that number is 3 halves.
So if you were to have like a phase shift in
Okay.
the parentheses,
Okay, let's just hang on, because we're going to do another problem and we're not done with this one. Okay, so can you just hang on to that for a second?
okay.
Just 1 second, hang on to it. Is it an emergency? All right, hurry up. Now, I got to write the cosine equation. I want you to think about this for a minute. If I'm thinking of this as a cosine, cosines start at the top of the hill and end at the top of the hill. So if I'm thinking of this as a cosine, I would have to be looking maybe at that part of it. Now, is that still the same picture, the same curve? So the amplitude has not changed, the period has not changed, and the vertical shift has not changed. The only thing that's different about the purple curve is where I start. I am now starting at pi over 3. So my phase shift, or my parentheses, is x minus pi over 3. All right, now I'm done with that one. So Brenton, you still have a question?
So when is it when you need to put 3 over 2 with the x instead of like outside?
You don't.
You don't?
You don't.
Okay.
Now, in this equation, because that's a 0, this equation could be written like this.
Okay.
But no, when you are building your own equations, that period number has to be, it'll be factored out.
Okay.
It has to be factored out when you graph. Okay? All right, now there's another one of those. So let's do the second one. This is 12B. Okay, so everybody's got this because I'm going to erase it. All right, so now we've got another equation. And let's see. So I got a point right here. And a point right here. Right here. All right, so here's sort of my picture. All right, and I'm going to do the same thing. I'm going to fill in these same blanks. All right, so the first thing we got to do is kind of just figure out, okay, are we going to look at this as a sine or cosine? It makes no difference. When I draw in my axis, because that's the axis that it's now oscillating across, would you agree? Does that make sense to you? When I draw that in, since this is right there, that looks like a sine curve to me. Would you be okay with that if we did that? There are lots of different answers to this question, so we kind of just have to agree, okay, that looks like a sine curve. So if I'm going to write a sine curve, what's my amplitude? 2. What's my vertical shift? How far have I picked that curve up? 4. Where's it supposed to be oscillating? 0. That axis is now up there at 4. So I've picked it up 4. That's out here. If I look at this chunk from this dot to this dot, I have no phase shift. Would you agree it's starting where it's supposed to start for a sine curve? And then what's my period? Well, if I go dot to dot, how far is that? 4 pi over 8 or pi over 2. So the period is pi over 2. So 2 pi divided by this number, whatever this missing number is, 2 pi divided by that number needs to give me my period. Dot to dot. How far is that?
Pi over 8. Oh, okay.
So pi n equals 4 pi. So n equals 4. So this number is a 4. And there's my sine equation. Now, remember, the cosine equation is going to match exactly, except you're going to start in a different place. So you're still going to have a 2 here, you're still going to have a 4 here, and you're still going to have a 4 here. If you're thinking of this as a cosine, no, you have to find the place where the cosine's supposed to start. So I like to go top of hill to top of hill, but you could go bottom of valley to bottom of valley. That would also be a cosine. It's whatever you want to do. If we did that, and I'll do it just for the sake of argument, if we went from here to here, that is a cosine curve. But it is upside down. So if you went that route, this would have to be a -2. And then you would have x plus pi over 8. If you went with the purple. Now, could you go from x to x? That would be a positive cosine curve, so we'd be back to 2. And the phase shift would be positive pi over 8, so it would be x minus pi over 8. Now, you don't need both of those. I did both of those to show you that you have options. There are infinitely many equations that could be written depending on which chunk you choose to look at. Got it? All right. Good question, Sarah. Thank you. Anyone else have a question about something that you have been, you tried it, you just couldn't do it, or you remember something from class and you think, oh gosh, we haven't done one of those in a while and I forget how to do it. Brenton?
For number 11 on the review sheet, review sheet 4, when you have, when it is sine 2.3, you just leave it in degrees.
Okay, so let's look at same worksheet number 11. Let's run through these because we can do them pretty quickly. My suggestion to you is, all right, notice, first of all, when you look at that, there's several problems there. Some of them are in degrees and some of them are in radians. All right? You are either going to have to be very aware and switch back and forth over and over again, or why don't we set our calculator one way or the other? Mine's in radians, so I'm just going to leave it in radians. And then I'm going to go through and do all the radian problems at once. Does that make sense to you? Then I'll switch it to degrees and do all of the degree problems. All right, so let's all go to radians because that's what Mrs. Ford has. And it's all about me. All right. So, A, that's a radian problem. How do I know? There's no degree mark. So I'm going to press sine 2.3, and the answer is 0.7457. Everybody get that? Easy.
On the test, will it tell us how far around?
Yes.
Sine
Yes,
what?
it will.
Sine 2.1.
2.3. Take a picture of somebody's thing. All right, what's the next radian problem? C. So we're going to do tangent pi, and we're going to use our pi button, divided by 7. Tangent pi divided by 7. I got 0.4816. These are just plug and chug. All right. Oh, how about E? Now, E is going to be a little bit harder because why? We do not have a secant button. So remember when we type this into our calculator, secants are 1 over cosine. You do not take the reciprocal of the angle. You type 1 over cosine. Secant is 1 over the cosine. So 1 divided by cosine, 8 pi, use your pi button, divided by 9 equals -1.0642 is the answer. 1 divided by cosine, 8 pi over 9. Okay? Now, those are all the radian problems. So now I'm going to change my calculator into degrees. I'm going to go back now and do the degree problems. So, do you remember how to put in cosine 12 degrees 11 minutes? So, cosine 12, second apps, choose degrees. 11, second apps, choose minutes. 0.9775. Nod or something? Okay. Next degree one, cotangent 10. 1 divided by tangent 10. Boys and girls, if you want to type in a cotangent, you have no choice, 1 divided by tangent. If you want a cosecant, 1 divided by sine. If you want a secant, 1 divided by cosine. So the answer is 5.6713. And then the last degree problem, do you remember how to get your seconds in there? Oh wait, first of all, it's a cosecant. So it's going to be 1 divided by sine. We got to start with that. 1 divided by sine. 18 degrees. 11 minutes. And 19 alpha plus, that gets my seconds, 3.2036. All right, that's a little calculator review. There will be a calculator part to the test. So you probably won't be asked to do 6 of those, but you may be asked to do some problems like that. All right, what else? Anything else you can think of? Oh, while we're on this page, cross out number 24. We did not do the inverse graphs and aren't going to do the inverse graphs. So cross off 24. 21. As arc sign, yep. That's the arc notation. The arc notation is the same, it's kind of the old-fashioned notation for inverse sign. So you will occasionally see arc sign. It means the same as inverse sign. Has the same rules. So remember the rules associated with this. If you were doing an inverse sign problem, you would only look for an answer in quadrant 1 or 4. Same thing with arc sign. They're the same. You handle them exactly the same. Alrighty? Okay, so which one did you say, Jason? 22? A, B, or C?
Let's go B.
B. B says, find the sine of the angle whose cosine is 1/3. Find the sine of the angle whose cosine is 1/3. Valerie, what are you doing, sweet pea? Oh, I know, but are you doing something legit, or maybe you should be paying attention to this? All right, this is not a calculator problem. So we're going to find the sine of the angle whose cosine is 1/3. So what do we start by doing? What do we do first? Draw a picture right here. What's that angle look like? Well, what quadrant is it in?
Second.
Well, it's either in the first or the second. That's the only place I could draw that. But since that's a positive number, it'll be in the first quadrant. Cosine 1/3. Pythagorean theorem would say the square root of 8 or 2 root 2. What?
We're going to be a 1, 2, 3 triangle. Not be able to tell that.
1, 2, 3.
Oh, wait, my bad.
We don't have a 1, 2, 3 triangle, right? In fact, a 1, 2, 3 triangle would be impossible. Can you tell me why that would be impossible?
Because the hypotenuse is smaller than the side.
Well, forget, not even in right triangle land. Think about having a piece of, a straw, 1 unit long, and another straw 2 units long. Is there any way you could take, now remember, those two add up to 3. So if you laid those 2 down, they would make 3. Is there any way to raise them up and have them meet? There's a theorem in geometry that says 2 sides of a triangle must add up to be more than the 3rd side. So that wouldn't even be possible. All right? We don't have that. We have this triangle right here. What do I want to know about that? It is not a special triangle. I don't care. I want to know its sign. So the sign would be 2 root 2 over, right, opposite over hypotenuse. Right? All right, what else?
So then on A, would you find the angle?
A, what number is this?
22.
22. A says find the angle whose tangent is negative root 3. So you are finding an angle in this problem. So you're going to start the same way you did here. You're going to draw it. Except you're going to draw it in quadrants 1 and 4. Right? Since it's negative, we'll put it in 4. Tangent, make that a fraction. Tangent is negative root 3 over 1. Now we have a special triangle because that's a 1 and a root 3, so this is a 2. How big is this angle right here?
Negative
60. Be careful when you answer the question though. It's not 60, it is negative 60. The answer is negative 60. When you go down to form your angle, it's a negative angle.
Can we do number 25 on that same one?
25. How large is an angle determined by a 2/3 clockwise rotation? So think about, I really start here, and I'm going to go 2/3 of the way around clockwise. So 2/3 of the way around clockwise. Now, what does the fact that I'm going clockwise tell me?
Negative.
It's going to be a negative angle. Now, what if I went all the way around? How big would the angle be if I went all the way around?
Negative
360, the negative 360. I'm not going all the way around. I am going 2/3 of it. So what's 2/3 of 360? This does not need to be a calculator problem. Oh my gosh. 2/3 times 360. How many times does 3 go into 360? 120. 2 times 120 is 240. Your answer is negative 240. What if we wanted to do that in radians? I did it in degrees. Now it's still going to be negative. That clockwise is clockwise. That's still going to be negative. But instead of taking 2/3 of 360,
2 pi.
I take 2/3 of 2 pi, which would be 4 pi over 3. Right? What else? We're watching the clock. You're going to get out of here soon enough. Don't worry about it. We have a test tomorrow.
For 22.
That should be our focus. What, Brenton?
22C. How do you have root 2 over? Oh, never mind.
Well, when you see root 2 over 2, Brent, that is a little bit tricky.
I see, but it's like.
It's 1 over root 2
Yeah.
rationalized. Yeah, so you kind of have to think backwards. Right?
Yeah.
You can't have the square root of
So to get this answer, you would have gotten this first and then done that, yeah. So we're just going backwards to the original form. Maura?
But like for a problem like that, how do you? Never mind.
do?
Yeah.
You sure?
Yeah.
Okay. Cassie?
For 21, how would the notations for that be arc sign X instead of, it's asking what is another?
Yeah, it just is.
Okay.
I mean, yeah, it just is. Back before calculators, the notation was arc sign, and then when everything became function oriented, they used the inverse function notation on the calculator, so it has become more popular. Yeah, just a random fact, but you need to be aware of it because depending on what book our book uses both. I don't know if you noticed that, but our book uses both. And, you know, you may get some teacher that's even older than me that's still using the arc sign notation. Just, it's the same thing, all the same rules apply. All right, I need to do another problem. I mean, I can make, I've got another sheet here that I found and have lost. Which one? All right, number 10. Find the area of the shaded sector, all right? Now, this is not arc length, so don't be thinking radius times radians, because even though the picture matches that, that's arc length. Arc length is radius times radians. This is a different thing. This is, the radius is 6, the angle is 100, and we are finding the area of that piece of pie. So in some ways, this is easier, because if we were doing arc length, we'd have to change our angle into radius. But if we're doing area, we don't need to. Who remembers how to do this? What's our strategy? Dylan?
Take 2 pi r, and then you would times that by 100 degrees over 360.
Okay, I wouldn't do 2 pi r. 2 pi r would be circumference.
Oh, wait, not or pi r squared.
Pi r squared. Yep, so I'm going to find the area of the whole. And then the rest of what you said is exactly right, Dylan. I'm going to find the area of the whole, which is pi r squared. That would be 36 pi. So if it said, what's the area of the whole circle, that would be the answer. But I don't want the whole thing. I want a fraction of the whole.
So would you put 100 over 2?
So the fraction I want is 100/360ths of the whole thing. So those are going to cancel. Those are going to cancel. Looks like 10 pi. Is that right? And I don't know if there's units on that or not, but let's say this was 6 centimeters. Then the area would be square centimeters. Okay.
Can we do 26 too?
26, number 2. All right. It's the last one we'll do, and then you can go to lunch. But stay focused. This looks like a doozy. Aubrey is walking at a pace of 3 miles an hour toward the Math Hall of Fame. So here's the Math Hall of Fame. Here she is, walking toward the building. At one point, her angle of elevation to the top of the building is 11. After 15 more minutes of walking, all right, so she's gonna walk 15 more minutes. Her angle of elevation is 13 and a half. That makes sense. She's getting closer to the building, so the angle's greater, right? How tall is the building? All right, we've done one like this before. What do you think?
You do the smaller inner circle first.
The little triangle first. So I gotta have something, I'm gonna call that y. And I'm gonna say the tangent of 13 and a half is x over y. Would everybody agree with that? I don't like the fraction, so I'm gonna say x equals y tan 13.5. Just multiply both sides by y, is that all right? Now I need to do the big triangle using the 11-degree angle. The problem is that is not a distance. So I need to figure out what that distance is, because y is a distance, x is a distance, this is minutes. So I gotta figure out how far she walked in 15 minutes. And if you dare to be confused, I'm going to blow up and explode, because it tells me she's walking 3 miles an hour for 15 minutes, which is a fourth of an hour. If you are walking 3 miles an hour for a fourth of an hour, how far have you gone? See, this drives me crazy. Distance equals rate times time. She's walking 3 miles an hour for a fourth of an hour. How far has she gone? 3/4, 0.75. I'm gonna use a decimal because it's easier to put in my calculator. But 3/4 is fine. Okay? So now my other equation, remember I got this one. My other one is going to be tangent 11 equals x over y plus 0.75. And if I do the same thing with that one I did for the first one, I'm going to have x equals, I'm going to bring this over, I'm going to distribute this over. So I have y tan 11 plus 0.75 tan 11.
You put the 0.75. Oh, no.
Wait, I thought that was,
Just bring this over here, multiply both of these by tan 11. Now, we have a system of equations, right?
You can set them equal to each other.
I can set them equal to each other. That's probably the best way to do it. So y tan 13.5 equals y tan 11 plus, I'm going to have to erase this running out of lane, 0.75 tan 11. Now we're solving for y.
So get the y's on both
So we
sides.
gotta get the y's on the same side of the equation. We should do a little rearranging, get the y's together, so that now that they're together, we can factor them out. So we set our equations equal to each other. Put all the y's on the same side, just move this over, pulled out the y, and now we'll know y. Y will be 0.75 tan 11 divided by this parentheses, and I am going to leave it in parentheses because that's how I'm going to have to type it in on my calculator. Okay, so I got to make sure I'm in degrees. I can't remember if I'm in degrees or radians. Also remember, when you go to type this in, your calculator will automatically, when you hit tangent, put in this parentheses, make sure you close it, and down here too. You're going to have to physically close all those parentheses or you won't get the right answer. I got 3.19, is that something? But whoa, stop, that is not the answer to the question. That is
That's only
y.
y.
And y is not the height of the building, which was the question. But the good news is, to get the height of the building, all you have to do is take the number on your calculator and times it by tan 13.5. And that will give you the height of the building, which is .7659, and go around whatever the directions tell us to round. What would be the unit on that?
Miles.
Miles. And why is that unit in miles?
Because it told us that at the beginning.
Well, the only distance I have in my problem is in miles, because she was miles per hour. So that's 3/4 of a mile. Oh. Alright, so when do I need you back? This time out here. I need you back in your seats at 12:25. Back in your seats at 12:25. Okie dokie smokies? 12:25.